तो ये भी वही है, ये भी वही है, it will not understand. And as you can see now, even though I have a single to do here, you see two of them on screen. So whenever you are doing lists, make sure you are passing in a key which is unique. Usually when you are doing a list, you are rendering something like LinkedIn posts. So in that case, you already know the post ID of this is what I'm going to render, the post ID of this is what I'm going to give as the key. So the key for this will be is key post ID, whatever is the ID in the database. Key for this will be whatever is the ID of this in the database. That you know for sure is always going to be unique. Cool. That is what how you do lists, which sort of you already knew. Keys is something new that we learned today. And how did we learn key? Why do you need keys? If you don't use keys, number one, there will be performance downsides. Number two, you will have this red error in your console always. And number three, in some cases, you will see inconsistencies also. Okay, the front end is showing something that does not appear in the React code. That is what are lists and keys. Next up, we'll understand inline styling. All right, we've already done this many times. Hopefully, you already know this by now. If you want to give inline styles to div, what do I mean when I say inline styles? कि जहाँ पे div defined है, right next to it you give it the styles, then you give it in an object that is passed inside the curly braces. So if I copy this, open Visual Studio Code, and let's say replace to do with my component and render my component over here. Then this hello world will be inside a div which has some background color and some background color and some text color. So if I open this right here and refresh, you will see hello the world is printed on the screen with some blue color behind. And if I change this to red, then as you can guess, the background color becomes red. So the only complicated thing here is double curly braces, which people get confused with. Which, as I've mentioned before, the idea is you are defining the style in an object, and you are passing that style object here. You can name this whatever you want. Whatever component styles. And when I refresh this, these styles are what are getting applied to this div now. Color white, background color red is what appears over here right now. If I want, I can whatever add padding, border radius, and all those styles would appear over here. This is slightly unlike how we have done styles until now. If you remember, in our HTML journey, this is how we did styles. Background color red. This is how we did inline styles back then. But in case of React, since this isn't really a div element, this is like an XML element that DOM render understands. This isn't really a div element. It just appears like it when you're writing React. So that is why you have to pass styles as an object, which you can pass either by separately defining it or cool. The only difficult bit, ये double braces क्यों है? And the double braces का reason is कि the thing inside is an object, and we have seen until now whenever you are passing props, you first wrap it inside single curly braces. Cool. That is all I have for inline styles. Eventually, we will be learning Tailwind, where styling is a whole different ballgame. We'll understand how you do styles using Tailwind. Most projects you will see or write yourself, you will be using Tailwind yourself. Let's move on to ooh, popular interview question. Not something you have to deal with for a while, but let's understand class-based components and how are they different from functional components. All right. Now we're going to understand the mildly legacy concept. Until now, the components that we have written are called functional components. But there is actually another way to write components in React called class based components. That is what we're learning today. Do you need them? No. Rarely do code bases use them. For example, this was one example I used to give to everyone. Okay, this specific React project still uses class based components, but they also had an open issue convert legacy React class components into the new functional components, and this is a closed issue now, which means they have also migrated to the functional components, same thing that we have been writing until now. But until some 2017, 18, 19, whatever that date was, class based components were the only way to create React components. They've slowly been, I wouldn't say depreciated, but no one uses them. Everyone uses this. This is what we have learned. Just for an interview question, let's understand how class based components look like. Earlier, React components were written using class based components. Slowly, functional components were introduced, and today they're the ones you'll see everywhere. Class based components are classes that extend another class called React.component, while functional components are simple functions that can use hooks inside them. This is what your counter component would look like. If you are using the legacy class based component, you would define a class called class counter, let's say, which extends React.component, a component that is exported over here. This is another class. This is how you would define the state. This is how you would define functions like an increment function. And you would have another function called render, where you would return your final div. So looks very similar to how we've written, right? This is how the functional component looks like. We had a state variable defined using the use state hook. Here, the state variable is defined directly over here as a sister object to this class, or whatever sister attribute to an object of this class. Here, this is how we define a function. Simply how you define a function inside a function. Here again, it is another attribute. Simply return this div from this function. And here we have a render function which returns this div. So functional components versus class-based components, that is the difference. If you compare them, you can use either. Doesn't matter. You can still use the class-based component. Let me show you. Let me copy over this class-based component and replace it over here. Take this import, put it on the top, and over here let me render the class counter, which again, class counter extends component. This is the state, this is the increment function, this is the render function. If I go here to localhost colon 5173, there's some error. See what the error is. Oh, I've imported React twice. Refresh. There you go. Increment still works. So like there's nothing out of the ordinary that this guy does. Whatever can be done using class-based components can today be done using functional components. Whatever can be done using functional components can be done using class-based components. This is much harder to read. A very different way to maintain state over here, and update state. This is how you update state. You call this dot set state. You call this dot set state, and there is a global, not a global, but like a state object at the top. Yahan pe you can in our class-based components, sorry, functional components, you can define multiple state variables. Here there is a global state attribute for this counter. Here is where you have to define all of your state variables. If you had to dos, you would define them over here. If you had something else, you would define them over here. And this is how you would update the state. Versus in our functional components, we just call the set count function, for example, the set count function to increase the count. Overall, this is how you do state and initialization in functional components. This is how you do state initialization in class-based components. This is how you define a function here, define a function here, return some HTML, return some HTML. Cool. Hopefully that is simple enough. That's how functional components and class-based components are different from each other. Do we ever use this? No. Was this the norm before in React? Yes, this was the only way to create components. Slowly this became much more adopted. Now everyone uses this. This has sort of become legacy. All right, you can't use hooks over here. Use state has no concept over here. Use state, use effect were all meant for functional components. None of this is meant for class-based components. You will never have to write this now, thankfully, in a new project. So for sure, if you write it, it's a red flag. But in an old project, legacy project, you might look at it, and then you will have to pattern match and understand state initialization, defining functions, and rendering the final component. Cool. That's all for class-based components versus functional components. Next up, let's understand lifecycle events, which was like a proper thing in class-based components and something we sort of do in a very ad hoc way in functional components. Let's get into that next. All right, let's understand lifecycle events next. We've sort of done this once for functional components. We didn't really give it a name though. So today, let's understand how they work in class-based components and their equivalent in functional components. In React, Life cycle events refer to specific points in a component's life where you can execute code in response to changes or action. These events help you manage tasks such as data fetching, subscription, cleaning up resources. Have we seen this in the past? Does this give us deja vu of use effects? Class based component lifecycle methods are methods that let you hook into, where is it, refer specific points in a component's life cycle. What is it? Life cycle event. When was the component mounted? That is a life cycle event. When was the component unmounted? That is a life cycle event. So this component that we have written could be a class based component, could be a functional component, doesn't matter. How can I hook into its life cycle events? For our functional component, we already understand. If I want to hook into, okay, whenever this count variable changes, I want some code to run. I can create a use effect, give it count as a dependency. This code will run every time the count variable changes. For this use effect that we have right here, since the dependency array is empty, this code will run when the component mounts. This code will run when the component unmounts. This is me hooking into the life cycle events. This is the mounting life cycle event. This is the unmounting life cycle event. If I copy this, if I go to, whatever my component over here, if I render this my component, you will see the component mounted log will come on the screen right now, and the component mounted or count updated log will come on the screen. If I open localhost colon 5173, notice what logs come. Component mounted or count updated came, this log right here, and component mounted, this log right here came, because these are the two effects that are running in response to the component mounting, the count variable getting initialized. Now every time I increase the count variable, what happens when I click on the button? Set count, count plus one, or if you want to get fancy, then the arrow function syntax that we had written. In this case, this will also work. So when I click on increment, component mounted or count updated gets rendered, because I haven't really hooked into a life cycle event. I wouldn't call this a life cycle event. A life cycle event is more like component mounted, component updated, component unmounted. This is more like the count variable updated. So I wouldn't call this a life cycle event. Nonetheless, you understand, if I want to hook into a variable changing this specific event and run some logic on top, then I can do that by using the use effect hook in functional components. And more specifically, if I really want to hook into just the life cycle events, which is the most important thing, which is what you will be doing most of the times, then this dependency array is empty. The dependency array that you pass is empty. And then all the code that is put over here, that code will run on mount. All the code that is put over here, that code will run on unmount. That is already something that we can see. If I refresh, component mounted gets rendered. If I write the code over here to unmount this specific component, we have done this in the past. Hopefully you can do that by now. If I write the code at some sort of a state variable const is component shown, comma, set is component shown equal to use state true, and then I conditionally render this is component shown, then render this. Then what will happen is, if I change the state variable, let's say every 5 seconds, then this will get unmounted. And whenever this gets unmounted, you will see component will unmount gets rendered on the screen. Cool. These are how you hook into life cycle events in a functional component, and something we have already done, something you would be doing in your life usually. Now, if you want to see how this used to happen in legacy class based components, here is how it used to happen. When you would define your component like this, class, whatever the name of the class is, extends react.component, constructor के अंदर you would initialize the state. You could override a function from this react.component class called component did mount. And यहाँ पे जो भी आप logic लिखते whatever logic you would write here would run when the component mounts. Similarly, component will unmount. Whatever logic you would write over here would run when the component would unmount. And another one was component did update anytime the state changed or anytime the props to this specific component changed, the props or the state changed, then this component did update would trigger. This is like a use effect only, but the dependency is everything in the state and everything in the props. When that becomes a dependency, component did mount comes into the picture. And here you can find कि अच्छा क्या change हुआ है. Is the tab changed? Do I need to refetch something from the notifications tab like we did in the last video? If you remember, we were doing something like we created a simple tab interface where I could go from one tab to another tab to another tab, and we were storing this in in a state variable. And whenever this state variable would change, I would send a backend request. The same thing you can do over here. Only thing is you will have to check okay, what was the previous state and what is the current state by running whatever this dot state, and then compare ki, has the tab changed. If the tab has changed, then refetch things from the backend. So this is how you would hook into lifecycle events in the existing old class-based components. Do you need to worry about it? Thankfully not. No one writes code like this. But the term lifecycle components lifecycle of components or lifecycle events, sorry, was introduced in class-based components. And thankfully today in functional components also, you can do everything that can be done over here. You can run some code when the component mounts. You can run some code when the component unmounts. You can run some code whenever the component changes. The same thing I'm doing over here, running some code when the count variable changes, running some code when the component mounts, running some code when the component unmounts. That is what are life cycle events in React. You don't need to know this term anymore, not very relevant after class-based components went away, not really used as such. As long as you understand use effects, when to use them, you're good to go. You don't need to know the term, but it's good to know the term for interview preparation. If some old person who's only used class-based component has this as an interview question, you should be able to respond. With that, we will move on to error boundary. Again, some slightly legacy thing. And the reason I've introduced it here is because you're good to go. You don't need to know the term, but it's good to know the term for interview preparation. If some old person who's only used class-based component has this as an interview question, you should be able to respond. With that, we will move on to error boundary. Again, some slightly legacy thing. And the reason I've introduced it here is because this is where you unfortunately have to use a class-based component only. So I used to work at this very big company, and throughout the code base, there was just one class-based component. That's when I went down this rabbit hole of error boundary and how this one thing functional components, yet you have to use class-based components for this. Let's understand this next. Thing that we're learning is the boundaries. Let me take you through, one real use case where I saw it in actuality. One day I was on this YouTube dashboard and I saw everything else is working correct. But this specific card that you see over here, that showed me कि sorry, there is an error, and there was a button to refresh. I tried refreshing a few times, it did not fix it. But that is the first time where on a big website I finally saw कि अच्छा, error boundaries are being used the right way. The name itself is error boundary. It lets you contain errors, and hence it is called an error boundary. What happens is it might happen that some API request over here is failing, or some API request in this card is failing. So when that happens, You don't want your complete application to crash. You only want this specific thing to fall back to a component that says, sorry, this data cannot be loaded. You don't want your complete application to crash. That is where error boundary comes into the picture. As the name suggests, it lets you bound an error. यार इसके बाहर नहीं जाएगा error. If there is an error here, that's fine. We will fall back to some other UI here, but we will not let the error propagate to the full website. We don't want the website to crash. Let's try to simulate something like this and recreate something similar to what I saw here. Let's try to create two cards over here. So let me get rid of everything. Let me create, function card one and then function card two. Inside the first card, let me return something like div hi there and add some style to it. Backgrounds 20, and then the same thing over here where let's say write hello. All right, I have two cards. Let me render both of the cards here. Card one and card two. They sort of look ugly, so let me add some padding. Something like this. We have two cards over here. Now, let's say one of these cards has an exception. Inside a use effect, you send some backend request. We'll be doing this eventually. Eventually, when we create a full stack application, inside a use effect, we'll be sending a fetch request, which might fail, let's say. Or if you want, you can just throw a new error inside this component, error while rendering. And you will see your complete website will crash. If I comment this line, then we're good to go. If I uncomment this line, if I throw an error in the first card, then the application breaks. But the error was just in the first card. Why can't we contain the error right there? Why do we have to make the complete website go down? As I said a while back, the thing that happened when I was on this page was this card sort of broke. And here I saw whatever, the UI is down. Please press XYZ button to refresh this specific card. Why can't I do something like this? Why can't I have a fallback UI for card one? Okay, if there is an error here, fall back to a different card. That is what error boundaries let you do. Error boundaries are React components that catch JavaScript errors in their child component and display a fallback UI. That is exactly what we want. We want to show a fallback UI if there is an error in our, let's say, card one component. The way it works is you have to first define an error boundary class based component. As I said, this doesn't work in functional components right now. The only reason you might have to use a class based component, and also feel free to use it as a black box, is that this specific class based component you need to understand a little bit, but at the very least use. What is this error boundary component? The constructor does nothing. It just sets the state to be has error false. And this specific function, the get derived state from error function, is a function that gets called if any of the child throws an error, and this updates the state to be has error true. And if you look at it in the render function, I say if there is an error, then render this fallback UI, else render this dot props dot children. Do we remember children? Yes, Harkirat. In class-based components, the way you get props is this dot props dot whatever the name of the prop is. In our case, we want if I am wrapping this card component inside the error boundary component, if I am wrapping this card component inside the boundary component, error boundary component will get this card as the children prop, and that is what it should render unless the error has been thrown. अगर error throw हो गया है, then show the fallback UI. Error has not been thrown, show the original UI. Let's see this in action. Let me copy this class, and you can paste it here. You can move it to a separate file, whatever is comfortable to you. Let me just paste it here. File has become a little bit bigger. So you can also put it in a separate file and export it from here. React is imported, react.component will be available. Let's see what the UI looks like right now. Can you see there is a fallback UI that appears? Because I've wrapped this card inside an error boundary. And in the error boundary, I have said, KR, if you look at the render function, if an error has been thrown, then show the fallback UI, else show the original UI. So if I don't throw an error in this card one component, then original card comes. But if there is ever an error thrown, my complete app doesn't crash. Just this part fallbacks to a separate card. And ideally, this fallback UI should also look something like the same card. The fallback UI should do something like this. Something went wrong. So that if it crashes also, UI wise it looks the same. Of course, the message inside changes. Okay, something went wrong. Please try again later, or whatever, refresh your page. So that is what an error boundary is. As I said, you can also take this as a black box, by which I mean, copy paste this into your very big code base, because that is what most companies do. Look at any open source code base of any company I've worked at, or even the closed source company, code bases before. This is sort of a black box that is introduced, and anytime there is a crash, this fallback UI is what renders on the screen. If there is not a crash, then the original thing renders on the screen. Cool. That is what the error boundary is, and super useful in, or super needed in, a mobile app, because mobile apps crash a lot, or components there crash a lot. So over there, you should have error boundaries and course company, code bases before. This is sort of a black box that is introduced, and anytime there is a crash, this fallback UI is what renders on the screen. If there is not a crash, then the original thing renders on the screen. Cool. That is what the error boundary is, and super useful in, or super needed in, a mobile app, because mobile apps crash a lot, or components there crash a lot. So over there, you should have error boundaries to make sure the app doesn't crash. It's a very bad experience if the app crashes, and very hard to update the app also. So over there, though, this matters a little too much. If you are writing React Native code, there is heavy emphasis on error boundaries. Websites may, number one, the number of times the error is thrown is lower, and number two, if it is thrown, it's easier to fix and deploy it to a website, much harder to deploy it on a mobile app. So you will see this much more in React Native, but here also, always a good idea to wrap your uh, components that can throw an error in an error boundary. Right now, what will happen is I have not wrapped card 2 inside the error boundary. So if card 2 crashes, then the website will still crash. As you can see, website crashed. But if I wrap card 2 inside an error boundary also, then the error over there will also get caught, and both of them will fall back to the other UI. Cool. That is what error boundary is. Next up, we are going to understand the last concept for today, which is fragments in React. All right. One very important sort of mistake you will see all beginners make in React is, and they'll always get confused by this, is okay, they will try to return something like this. Here I have a div and then another div right next to it. Here I've written hi there. Here I've written hello. But as you can see, the React compiler is sort of complaining over here. Is this easy to understand from first principles? I can never return this to from a function. This is a function. Okay, this might syntax might feel weird, so let me write it like this. This is a function that I have described over here. I can't return two space two from it. I can't return a string and then another string from it. I can only return a single string, right? Or a single number. So similarly, I can't be like return first div hi there, and then I'm going to have a second child div which will have hello right next to it. You can't return two things from a div. Sometimes you will try to wrap this inside round basis. Here this might work, but here also the problem remains the same. React expects whatever function you are that whatever function is returning some content, it should return a single top level div. अंदर आपको जितने बच्चे डालने हैं डाल लो. Put as many children you want inside, but there should be a single top level div, span, or something else that wraps all the children. You can never return something like this. React will begin to complain. JSX expressions must have one parent element. We have two elements. कह रहा है इनको एक parent में डाल दो. JSX elements must have one parent element जिसके अंदर we have two children right next to each other right now. So this is just one thing to know. And whenever you are seeing this error, what are you going to do? Simple. Wrap your whole application or this specific component inside a div and you are good to go. Error gone. If you look at the final code on the final website, it looks right. If I remove this top level parent, then of course there is a problem. This is great and good enough. Most of the times you would just do this and forget. But there is one small problem here. I have introduced an extra div. If you look at the final structure here, what if I wanted कि जो मेरा React container है, whatever is my React container, let's see, if I go to elements, go make this smaller, there you go. This div ID equal to root, this is my React container. I wanted two children inside, child 1, child 2. I do not want a parent div, which gets two div insides, even though it makes no difference in the UI. UI still looks the same. But you are very adamant. Okay, I don't want this. I don't want this extra div here. The root div itself should have two children. So in that case, you can use fragments in React, which basically is something like this. Okay, rather than putting div or a span, don't put anything inside. Just write a empty opening braces, empty closing braces. And if you look at it now, div ID equal to root indeed has two direct children. I did not have to introduce an extra div over here inside which we have two children. I have sort of gotten rid of these extra, um, you know, extra one div parent over here, even though no real difference in the UI, but still, you know, just for kicks, if you feel like it, if you want to get rid of one extra div over here, you can by using React fragments, which you can use like this, or you can also import fragment from React, import fragment and React and wrap your app like this, or no need to import fragment from React. Opening empty tag, closing empty tag slash div over here. Then you will see that extra wrapper div in the final output. You will see first a div. All right. That is what are fragments in React. Let's go through the slides also. In React, a component can return a single parent element, but it can contain multiple children within the single parent. So this code is wrong. And this code is right. And we are using React thing different fragment React. And that covers probably some basic foundations for React. We'll understand single page applications, layouts, and building a website during the live class. Then we will go into some complex state management. We will understand rolling the state to the top of the application. Then we will understand context API. We'll understand prop drilling. And then lastly, we will go to some framework for doing state management. We will see which one. Recoil, Redux, the third one that's popular. Skipping my head right now. There's one called MobX, I think. And then there's one more, state management libraries in React. There are like many of them. We've only used React and Recoil until now. But let's see what are the top 7. Redux, Zoostand was the one that I was talking about, and then there's MobX and there's Recoil. So we'll see which one of these we pick and try to understand. All right. With that, let's end it, folks. I will see you guys in the live class next.